Pleasant day to all. We are Group 6 of ITS105-BM1 and today we are to examine and discuss digital ethics, a critical field that addresses moral principles and conduct in our increasingly technology-dependent society. We will first establish foundational ethical concepts and frameworks, then explore how these principles apply specifically to information technology professionals and users. Understanding these ethical frameworks is essential for making responsible decisions in digital environments and addressing the complex moral challenges that emerge from our reliance on technology. To start off, let us first discuss ethics fundamentals. Ethics represents a systematic code of behavior established by social groups to govern individual conduct. Unlike static rules, ethical frameworks evolve to address changing societal needs and facilitate organized community functioning. We must distinguish between three interconnected concepts. First, ethics constitutes group-defined behavioral standards that provide collective guidance, whereas morals represent individual principles that inform personal judgments about right and wrong decisions or actions. On the other hand, laws establish enforceable regulations with prescribed penalties for violations. Critically, legality does not guarantee ethical validity. Contemporary debates surrounding abortion rights and medical marijuana illustrates this disconnect, where legal frameworks may conflict with diverse moral perspectives within society. Integrity requires consistent adherence to personal ethical principles while extending mutual respect in interpersonal relationships. Let us now move on to the factors influencing ethics. Individual value systems emerge from the interplay between virtues, positive behavioral patterns like fairness, generosity, and loyalty, and vices, negative tendencies including vanity, greed, envy, and anger. These systems reflect complex influences, including cultural background, age, religious belief, educational experiences, and life circumstances. Contemporary factors contribute to increased unethical behavior patterns, which is 1. Globalization, which creates complex multicultural work environments that challenge consistent ethical application across diverse contexts. 2. Economic pressures, which incentivize organizations to prioritize short-term financial gains over ethical considerations. Moreover, power dynamics or power corruption enable successful individuals to develop inflated confidence in their ability to manipulate situations, often leading to moral compromises. On to corporate social responsibility and decision-making. Corporate social responsibility represents an organizational commitment to ethical conduct through responsible consideration of stakeholder impacts, including shareholders, consumers, employees, communities, and environmental systems. Organizations pursue CSR initiatives for strategic benefits, building community goodwill, establishing operational consistency, developing sustainable business practices, reducing legal liability, and maintaining positive public reputation. Effective ethical decision-making follows a structured methodology. First, define problems through comprehensive fact-gathering while avoiding assumptions. 2. Identify alternative solutions through collaborative stakeholder engagement. 3. Evaluate options based on effectiveness criteria, risk assessment, and resource requirements. 4. Implement chosen solutions with clear communication strategies. And finally, 5. Monitor outcomes to assess goal achievement and identify unintended consequences. So why does information technology ethics matter? Information technology's expanding influence amplifies ethical considerations as human rights often receive insufficient attention during technological development processes. Critical IT ethical issues include government surveillance systems that create tension between privacy rights and security necessities. Workplace monitoring raises questions about balancing organizational asset protection with employee privacy expectations. Widespread copyright infringement through unauthorized digital content distribution causes significant economic harm to creators. Data breaches facilitate identity theft through compromised personal information. Unsolicited marketing communications represent intrusive business practices. Academic institutions face challenges with digital plagiarism, undermining educational integrity. When it comes to IT professional relationships, IT professionals must navigate complex ethical relationships across multiple stakeholder groups. Like employer relationships, these involve managing job responsibilities, protecting proprietary information, and potentially engaging in whistleblowing activities when organizational misconduct occurs. For client relationships, these require maintaining objectivity while avoiding conflicts of interests that could compromise service delivery. As for supplier relationships, these demand vigilance against bribery while establishing effective internal controls. Professional peer relationships emphasize mentoring responsibilities and maintaining collective professional integrity. IT user relationships focus on preventing software piracy and addressing inappropriate resource utilization. And lastly, societal relationships require balancing technological innovation with public welfare considerations. When it comes to building IT professionalism, professional competency in information technology requires multiple characteristics: specialized technical expertise, adherence to ethical standards, consistent quality output, reliable commitment fulfillment, effective communication skills, and mentoring capabilities for less experienced colleagues. There are ways to improve a profession or IT profession. Professional development strategies include subscribing to established codes of ethics, participating in recognized professional organizations such as ACM, IEE, CS, which obtain relevant industry certifications, and supporting licensing initiatives. As for certification and licensing, certification programs demonstrate specific skill competencies and are typically voluntary, while professional licensing represents government-mandated requirements that include mandatory ethical obligations and regulatory oversight. When it comes to software engineering ethics, software engineering professionals operate under 8 fundamental ethical principles that guide professional conduct. First, public interest considerations must inform all professional activities. Second, client and employer relationships should serve stated interests while maintaining public welfare priorities. Third, product development must achieve the highest attainable professional standards. Fourth, professional judgment requires maintaining integrity and independence from external pressures. Fifth, management responsibilities include promoting ethical approaches throughout development processes. Sixth, professional reputation advancement serves broader public interests. Seventh, colleague relationships demand fairness and mutual support. Eighth, personal development requires commitment to lifelong learning and ethical practice promotion. These elevated standards reflect the specialized knowledge and societal impact associated with information technologies expertise. On to IT user ethics issues and solutions. In information technology, users commonly engage in 3 problematic behaviors. These common behaviors include software piracy, which occurs when individuals copy licensed workplace software for personal use without appropriate authorization. Second, inappropriate resource utilization that includes non-work-related internet activities, gaming, or accessing inappropriate content during work hours. And third, information sharing violations, which involve unauthorized disclosure of confidential employee data or proprietary organizational information. Organizational responses require comprehensive approaches or solutions. These are clear usage guidelines, which must be implemented to establish acceptable hardware and software utilization parameters. Second, acceptable use policies, which articulate the purpose, scope, behavioral definitions, compliance, monitoring procedures, and violation consequences. Another is technical controls or implementations that include access controls that limit data availability to authorized personnel, firewall systems that restrict inappropriate website access, and compliance monitoring systems. And finally, legal compliance or legal protections, which ensure adherence to relevant regulations and licensing agreements.
Now, for the ethical decisions in software development, the basis of ethical decision-making requires a strong focus on software quality as it directly influences safety, business success, and user trust. This makes rigorous design, testing, and ethical responsibility vital throughout the development process. High-quality software is especially important in critical fields such as healthcare, aviation, and defense, where failures can endanger lives. Poor quality systems can create safety risks, financial losses, and inefficiencies, which is why ethical choices in both design and testing are essential for reliability and trust. From a business perspective, software supports vital operations like banking, reservations, and industrial processes. Defects don't just cause costly delays and unsafe conditions, they also harm customer satisfaction and overall competitiveness. That means ethical decision making, balancing profit, speed, and quality is not just a technical requirement, but also a business necessity, directly impacting survival and long term success. To achieve high-quality software, developers follow proven strategies. Two common development methodologies are the waterfall model and agile methodology. The waterfall model is a step-by-step sequential process. It offers strong management control, but is less flexible when user needs change. On the other hand, agile is iterative and highly flexible, adapting to evolving requirements, but it demands significant time and effort from the development team. Alongside the methodologies, quality assurance testing also plays a crucial role. Dynamic testing, such as black box and white box testing, checks functionality and logic. Static testing, like code reviews and analyzers, helps catch errors early. And at a broader level, unit integration, system, and user acceptance testing ensure that software works correctly at every stage. When methodologies and QA are combined effectively, they reduce costs, improve reliability, and uphold ethical responsibility in development. Some of the toughest ethical challenges arise in safety-critical systems. These are systems where failure can cause serious harm or even death, such as medical devices, airplanes, cars, nuclear plants, and military equipment. Developers face dilemmas like should they prioritize safety features or reduce cost and time to market. Another difficult question is deciding when testing is enough, especially when lives are on the line. History gives us real-world examples of failures, like Toyota's acceleration and brake defects, faulty Covidian ventilators, and GM's defective airbags, all of which led to recalls, injuries, and even deaths. These remind us why ethical responsibility in safety-critical software cannot be compromised. Next is risk management, which is essential in software development. Risk simply means the potential for gain or loss, and it's measured by three factors: the risk event, the probability of it happening, and the impact if it occurs. Together, these determine the annualized loss expectancy or ALE. Developers and organizations use several strategies. First is acceptance, which is keeping the risk if fixing it costs more than the impact. Next is avoidance, which is removing the source of the risk entirely. Next is mitigation, which is reducing likelihood or impact such as adding redundancy. And lastly, transference, which is shifting the risk to another party like with insurance. Reliability and safety are also critical. A reliable system performs without failure, while a safe system operates without causing harm. Techniques like redundancy, such as backups or RAID systems, improve resilience, but human factors like poor interface design or operator error can still create risks, as seen in the USS Vincennes incident in 1988. Ultimately, effective risk management combines quantitative analysis with strong design, reliability, and user-centered safety. Now, let's look at contingent workers in IT organizations. These are people hired for short-term IT projects like installations or product development. They can be sourced in different ways. For example, temporary staffing firms recruit and train workers but don't usually provide benefits. Employee leasing involves co-employment with a leasing firm, while PEOs or professional employer organizations handle HR tasks, though the client still directs daily work. Another form of contingent work is the gig economy. Here, workers take on short-term, on-demand jobs such as coding, training, or documentation. Instead of receiving a salary, they're paid per project. Platforms like 99 Designs, Freelancer, Guru, Toptal, and Witmark makes these opportunities wildly accessible. Lastly, there are independent contractors who work under agreement but not as employees. By 2020, they were predicted to make up 40% of the US workforce. This growth has been driven mainly by cost savings and flexibility, but it also raises ethical questions about job stability, loyalty, and long-term sustainability for workers. Another type of workers in IT organizations are H-1B workers. They are people hired from other countries through a temporary US visa. This visa is for jobs that need special skills, usually requiring at least a college degree, and it lets them work in the US for up to 6 years. Companies use H-1B workers to fill important tech jobs when they can't find enough local workers, but relying too much on them can cause problems. For example, companies might stop training US workers, and if the visa expires, businesses lose talent while workers may be forced to leave. Business leaders argue the US doesn't have enough skilled IT workers, so they want more H-1B visas. But critics say too many foreign hires may hurt opportunities for American workers. The challenge is finding a balance between staying competitive and supporting local talent. Finally, we look at three more ethical areas: outsourcing, whistleblowing, and green computing. Outsourcing allows companies to cut costs and access global talent, but it also raises risks like hidden expenses, layoffs, cultural barriers, and data security issues. Whistleblowing occurs when employees expose illegal or unethical practices. While laws protect whistleblowers, they often face retaliation, lawsuits, or career setbacks, making it a difficult but important ethical act. Green computing focuses on eco-friendly IT practices, from designing energy-efficient systems to recycling electronic waste responsibly. Not only does this reduce costs and pollution, but it also enhances a company's reputation and shows a commitment to sustainability. In conclusion, digital ethics emphasizes integrity, responsibility, and accountability in all areas of IT, from software quality and risk management to workforce ethics, outsourcing, whistleblowing, and environmental sustainability. Each decision carries weight. Ethical decision making ensures that technology supports society responsibly, balancing innovation, business goals, human values, and the environment. As future IT professionals, we must remember that every line of code and every system design has ethical implications that can impact people's lives. And that is all for our presentation. Thank you for listening.